Okay, so this we read the opening statement. Sketched below is the graph of g of x equals a dot cos b theta. Okay, so um, they made a slight mistake there. They should have put x there instead of theta. That's fine. Now, as I said, a gives you an indication of the amplitude, while b gives an indication on your period. So let us focus on the a and b. The first question obviously says calculate a and b. So I want you guys to look at the diagram and tell me what is the period of the graph by just looking at the diagram. Not the period. Sorry, my bad. Not the period, but the amplitude. Sorry, the amplitude of the graph. Okay, someone says the amplitude is 2. Yes, yes. As I said, amplitude is just the distance. If you this is a wave, amplitude is a distance from there to there, or if you like there to there, the positive distance. So distance from here to there is clearly 2. So therefore, your A will either be a 2 or minus 2. All right, the A will be a 2 or minus 2. So now, how do you know whether or not it's positive or negative? Ne? You must know the graph of, or must know how the graph of cos x looks like. That's the only way you're going to know if the a is positive or negative. Look, the graph of cos x is the one in blue. The graph of cos x is the one in blue, ne? So cos x. Now, let me write there that it is cos x. Now, minus cos x, as I said earlier, is just a reflection through the x-axis. It looks like this. Reflection of this through the x-axis looks like that. Now, you guys see what happens? The original graph of cos x, ne, crosses the x-axis, the y-axis, sorry, at 1, positive 1. So now when you come across a graph of cos, ne, crossing the y-axis at a negative number, not at a positive 1 or a positive 2, or at a negative 1 or negative 2. Just know or that the number in front of cos x will be negative. So if it crosses at minus 1, it will be negative 1. If it crosses at minus 2, it will be negative 2 cos x, or negative 2 cos whatever it is. Are we together with what I just said? So you must always know the graph of cos crosses the if it crosses at positive, the positive side of the x of the y. If it crosses at a negative, you know that the coefficient there will also be negative. Now let's go back to our diagram. Do you see that this thing is crossing at negative 2? It is a cos function. This will then tell you that your a is negative 2. Having established that the amplitude is 2, you don't know whether or not you're gonna put negative 2 or positive 2 there. You check that fact. If it crosses the y-axis at a negative, this becomes negative 2. Delicious, ne? Let's talk. Amo, are you happy? Mholi? Ulwanile the ocean, shalom? Yes, yes. God is great, my daughter. Now let us go to B now. I told you that B involves the period, yeah? And how does B involve the period? I said that the period of cos and sine are given by 360 degrees over B. B is just the number in front of X. Even if it was a C or D, whatever it was, as long as it is the number in front of X, this is your formula. Now, let us find B by using this formula. Let us first establish the period and substitute it. We're going to establish the period using the graph. You're going to check where a point repeats. This is a turning point, the lower turning point of the graph. As you can see, this graph is going to go like this. So this point repeats there. And what's the distance from there to there? Can you guys tell me? 360. How do you see it? Our x here is 0 degrees as you have it. Our x there is 360. The distance is 360. If you can't see it with the naked eye, you just go this one minus that one. 360 minus 0 gives 360. So therefore, you're going to go to this formula, you're going to go 360 degrees equal 360 degrees over b, and you cross multiply, you have 360, b equals 360, and then you divide both sides by b because you're looking for, so by 360 because you're looking for b. So therefore b equals 1. Easy peasy, ne? Yebo, 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 yebo. Yes. Just a quick one as well. Use the graph to determine the value or values of x for which g of x is greater than 0. Whenever you get such a statement, g of x greater than 0, it means which part of the function, which part of the graph of g is above the x-axis. That's what this thing is saying. And if you get a statement like this, it says which part of the graph is below the x-axis. Let us explore this first. This means which part of the graph is above the x-axis. That's how you should look at it. This part is above the x-axis. Do you all see that? This part of the graph. Now, in an exam, you're not gonna draw that thing. You're not gonna highlight it. You need to represent that highlighted area mathematically. So how do you do that? Consider the x coordinate of this point that lies on the green part. Its x coordinate is somewhere between 90 and 270. The x coordinate of this point that is on the green part is it's a value between 90 and 270. The x coordinate of this point, the x coordinates of all of these points on the green part are between 90 and 270. So therefore your answer will be 90 to 270. We are excluding 90. We put curly brackets. We're excluding 90 and 270 because 90 and 270 lie on top of the x-axis. We're only interested in points that lie above the x-axis. That's your answer. Another way to represent it is like so. Still find x an element of 90 degrees to 270 degrees. Are we together? If the question, however, had said for which values of x is g of x greater than or equal to, this then means which part of the graph is above the x-axis or below, above or on top of it. I repeat, this would mean that this would mean which part of the graph is above or on the x-axis. So therefore, it will also include the points 90 and 270. Then your answer will become, instead of it being like this, it will have square brackets, which means we include the 90 and 270. Sisonke madoda. Yes. Then if a question comes like this, for which values of x is g of x less than 0, it means which part of the graph is below the x-axis. Let us look at the graph there. Let's find the part or parts of the graph that are below the x-axis. The parts we are talking about are this part below the x-axis and that part over there. So now let us then represent this first part here. This first part, let's consider this point. The x-coordinate of this point is somewhere there. It is below 90. The x-coordinate of this point is somewhere there. It's below 90, but above 0. The x-coordinate of this point is at 0, literally 0. So how are you going to represent? You're going to say the x-coordinate starts at 0. For this point, the first coordinate, it's at 0. It includes the 0 degrees to 90 degrees. But we exclude the 90 because the 90 is on top of the x-axis. We exclude the 90. Does that make sense, Matot? And you also include this part. You write it separately. The x coordinates here, as you guys can see, are above 270. All of these x coordinates, and then this x coordinate is included because also this point is below the x-axis. Sorry, its x coordinate is 36. So you're gonna write from 270, excluding the 270 because the 270 point lies on the x-axis, excluded, to 360. You include it because its point is literally below the x-axis. Sisonke Matiotia. Okay. Then The second last question here. Determine the range of h. Ne? So now, before we even move any further, h, we're not given the graph of h anywhere here. So it means that it is a new graph that they decided to create. Okay? So it says determine the range of h, it's a new graph, if h is the image of g, if g is shifted down 2 units. So h is a new graph that is created. How is the new graph created? They just take the graph of g, shift it 2 units down. So let's write down the expression of g. We found that a is minus 2, right? B is 1, so just leave it like that. Okay. Now, what is the range of the graph of g of x? Ne? This is h of x. This is g of x. We want to create h of x. But let's first find the range of h of x of g of x, this original graph. Range is the y value. So it is you writing down all of the y values from the minimum y value to the maximum y value of that graph. What do I mean by that? You're gonna draw vertical lines like this from the lowest point. The lowest point of the graph is here, is at -2. The highest point of the graph is there at 2. So a range is basically all of the y values on the graph. So the y value for this point is there. The y value for this point is so all of the y values are that on the graph are between the -2 and the 2. So therefore you're gonna write from +2, -2 to +2, including the values. That is your range. So now, if they tell you that if they ask you to find the range of a new graph G, which is just sorry H, which is just G shifted 2 units down, that means you're gonna shift the range 2 units down. You're gonna go like this, shift this thing 2 units down, so it's gonna be -2. It's gonna be -2 -2, shifting it down 2 units. Then this 2, then this 2 there, you also -2 to it. So therefore, your new range would be -4 is to 0. Do you guys see that? This point, the maximum point, is shifted 2 units down, so it's gonna be there. Your graph will turn like that. And then this point will be shifted 2 units, so it's at 0. This graph will be shifted 2 units down, it's gonna be at -4. So you see, it is there. So you see how the range goes from -4 to 0. Are we together? I'm gonna pause for just 10 seconds for you guys to, not 10, but 1 minute for you guys to analyze this. Analyze in 5 questions. Let me save this as well.